Another important concept in probability is the Venn diagram. The relationship between events and the corresponding sample space can be illustrated graphically by means of Venn diagrams. In a Venn diagram, we let the sample space be a rectangle and represent events by circles drawn inside the rectangle, as shown in the figure on the right. Now let's apply the concept of Venn diagram for events in sample space. Consider the events A and B. The union of two events consists of all outcomes that are contained in either of the two events. The union of A and B is represented by A, U, B. An example is shown on the diagram on the right. Now that you have known the concept of union, we must proceed with the concept of intersection. Consider the events A and B. The intersection of two events consists of all outcomes that are contained in both of the two events. The intersection of A and B is represented by A inverted U, B. An example is shown on the right. Another concept would be the complement of an event. Consider event A. The complement of an event is the set of outcomes in the sample space that are not in the event. The complement of an event A is represented by A apostrophe or A raised to C. An example is shown on the right. And finally, let's consider the last case, the mutually exclusive events. Two events denoted as A and B, such that A intersection B is an empty set, are said to be mutually exclusive or disjoint. So let's say, for example, let M be the set of vowels A, E, I, O, and U, and N be the set of R, S, and T. Then it follows that M intersection N is an empty set. That is, M and N have no elements in common and therefore cannot occur simultaneously. Let's apply now the concepts of union, intersection, mutually exclusive events, and complementary events. Consider the Venn diagram on the right. A union C would be regions 1, 2, 3, 4, 5, and 7. B complement intersection A would be regions 4 and 7, and the intersection of events A, B, and C would refer to region 1. Now we're going to proceed with the concept of probability tree. Let's consider an experiment of tossing a die. You are expecting 6 simple events for this experiment. By definition, a probability tree is a helpful graphical representation of a multiple-step experiment. Hence, from this probability tree, you could define the simple events as E sub 1, E sub 2, E sub 3, E sub 4, E sub 5, and E sub 6, so that your sample space will be 1, 2, 3, 4, 5, and 6, which could be denoted by E sub 1 until E sub 6. Now we're going to proceed with the probability of an event. The classical method states that if an experiment has n possible outcomes, this method would assign a probability of 1 over n to each outcome. So let's say, for example, the experiment is rolling a die. The sample space S would be 1, 2, 3, 4, 5, and 6. Therefore, the probabilities for each sample point has a 1/6 chance of occurring. We are now moving on to the concept of the probability of an event. If an experiment can result in any of n different equally likely outcomes, and if exactly n of those outcomes correspond to event A, then the probability of event A is n over S. For example, suppose that a card is drawn at random from an ordinary deck of playing cards. What is the probability of drawing a red card? The probability of drawing a red card will be equal to the number of outcomes for the red card divided by the total number of outcomes in the sample space S. The number of outcomes for the red card is 26, and the total number of outcomes in the sample space is 52. Hence, it will be 26 over 52, and when rounded off, equal to 1/2. Now we're going to explore the axioms and properties of probability. If A and B are any two events, then by additive rule, the probability of A union B will be equal to the probability of A plus the probability of B minus the probability of their intersection. However, if A and B are mutually exclusive, then the probability of their unions will be equal to the probability of A plus the probability of B. So let's say, for example, what is the probability of getting a total of 7 or 11 when a pair of dice are tossed? From this example, we let the event A for getting a total of 7 and event B for getting a total of 11. Since events A and B are mutually exclusive, then the probability of A union B will be equal to the probability of event A plus the probability of event B. The probability of event A is 6 over 36, and the probability of event B is 2 over 36. Getting the sum of it, it will be equal to 8 over 36, and when rounded off, equal to 2/9.